Now I'm going to get all the winning board combinations. And what I mean by that is that there are 12 possible winning board combinations. There are 5 rows, so you can get every number in each row, 5 columns, and then you have 2 diagonals, right? So that totals a 12 possible combinations. So each board has these 12 combinations, and only one of them, a combination, has to match 5 numbers in order for the board to win. All right, so that's what I'm going to do here, and the end result will be a list of sets. So I'm making each combination, each 5 number combination, a set, and you'll see the reason for that later. It makes it easier to determine winners. All right, so I'm going to convert the rows to a set, each row to a set, each column to a set, and each diagonal to a set. So I've already written the code that does this for each one. Let's take a look how it works. Now the rows are pretty simple. We're just going to use a list comprehension and directly convert each list to a set. So if I do get rows, and I'll just pass in the first board. So here are the first combinations. They're not going to be in the exact order. Sets are unordered naturally, but it should be those exact same numbers. Now the columns are a little bit tricky. What's going to happen here is I'm going to go through one column at a time like this, and then for each column, go through each row and just grab those numbers and place them in a set. So here's the code for that. We're not going to use a list comprehension, so we have to create an empty list first. So this I is actually going to be the column. So maybe I could have named it for call, instead of I, maybe more descriptive, but I is going to be the column. That's where we're going to create a set. So we're going to say, all right, when we're in this column, let's create a set for these 5 numbers. And then we're going to have an inner loop over here, which is going to go through the rows. It's going to go through one at a time like this. Okay, so then it's just going to add this number to the set. So here's the board. It's saying, all right, go to, this is column J. This is really, row J. That's the first thing. So it begins at 1, or at, the first one will be here. And this is going to stay the same for all 5 of those. So it's just going to keep going down here. It's just changing the row, right? And it is just picking up all of those in that column. So once it has this set, once it's gone through those 5, it'll just add it over here to the list, append it to the list, and then it'll start over, right? I will be 1. That'll be the column over here, right? And it'll just get the, the second number for each row and create a set out of those. The diagonal, and let's just look at those actually real quick. So get calls, we'll pass in the first one too. So here, let's just look at the first one, 0, 44, 45, 50, 87. And that's these numbers right here. So it did correctly get the columns. The diagonal, so this is kind of interesting. We're going to get them at the same time. So we're going to create the 2 sets, one for the left to right diagonal and the other for the right to left diagonal. So we're just going to make one iteration through the 5 integers. And look at how we do this. So through each iteration, we're going to grab the first row and the first column. So I and I will be the same. So let's just look at this one and ignore this one for a second. The second one will be 1, 1, then 2, 2, 3, 3, 4, 4. So it's going to grab this one, this one, this one, and so on. The other way, it's going to say, all right, get the first row and then 4 minus I. So it'll be first 0 and then 4. So it'll be 0 will be the first row and 4 will be the last one, like this. So that's how that one would work. Then it'll be 1 and then 3. So it'll be 1, 3, it'll be this one. And then it'll be 2, 2, which will be this one, and so forth. So it'll get this right to left diagonal. And then finally, we're just going to return the result as a list like this. So all of these are list of sets. So let's go ahead and take a look at that one, the diag, and we'll just put in the first board, and we should have, so here's this diagonal, and we can just double check. Okay, 22, 50, 64. That's this one, 22, 50, 64, so forth. So that looks good. And then finally, we have one more function that will go through all of the boards, and it's going to just combine all of the combinations for each each board. So it's going to gather all 12 of those combinations, and then it's going to return a list of these 12 combinations for each board. So again, it'll still be a list of 100. So there's 100 boards, and each item in the list will be a list of 12 sets. So it's a list of 12 sets. So let's get all of these. We can just say combos equals get all combos, and then we're going to just pass in all the boards. And just let's look at the first one. So here's the first list of 12 combinations. So these are all the ones I can win for the first board. Here's all the ones I can win with the second board. All right, so that's how you get all the combos. A little tedious, but we're just really breaking down the board to its components, which are just rows, columns, and diagonals. That's how you play the game bingo, and that's how we're going to have the computer play it as well.